Hello, Triggy students, and how you doing? And what we're getting into now is ambiguous case. Ambiguous case mostly is the angle side-side triangle congruencies. Again, if you remember being in geometry and your teacher going through the angle congruencies, there's such thing as like angle side angle and side angle side. I'm sure that you guys all wanted the teacher to write down, oh no, I'm going to do it, angle side side. Well, this causes problems with triangles. Triangles are not obviously going to be congruent under certain circumstances. And I'm going to go through those circumstances. And that's basically what we're going through right now. So let me get rid of all this. If you haven't already, get the notes from Power School. I already have all of this written out for you. When A is acute, then all these cases and scenarios. Make sure you write these down. This is your guideline on how to do well on the My Math Lab. And on the left-hand side of the screen, I created an example of each one. First of all, whenever I talk about H represents not hypotenuse, oh boy, that's a triangle, but the true height of the triangle, like straight down, the altitude, usually what it's called. So just understand that the H here is not hypotenuse, it is the height, the true height. So let's talk about the first one. Let's talk about when A is less than H. On the left-hand side, this is an example when A is less than H. Basically, the A value is not long enough to stretch down and make a triangle. It just kind of wobbles back and forth, which creates no triangle, and that's the first example. The second example, and let me just get this sized up just right. There it is. It's when it says A equals H. Now, this is very rare that this happens. This is very, very rare because it's really just going to make a right triangle. Well, if we're going to have a right triangle, then I would recommend to you then just use SOHCAHTOA, Pythagorean theorem, but this is a very rare case, so I'm going to say don't count on this one too much. I'm actually going to go down to the next one here, and I'm actually just going to make this slightly larger. What you should notice here is that the A value, actually when it swings back and forth, is a possible it can make two different triangles. It can either make a one at B1 and or another triangle at B2. So this one is kind of a confusing process. So definitely we'll try to get that one on the last step. And the last one here, when A is greater than B, so I gotta slide this so it's greater than 9. As you can see right there, it's greater than 9. It only makes one triangle. It's on the right-hand side. When this swivels and goes back to the left-hand side, we can't make a triangle on the outside of that 30 degrees. It's not even possible. So again, when you get this case, then we only have one triangle. All right, let me close the GeoGebra and I'll open up My Math Lab. Okay, now that I have a My Math Lab assignment open, I'm going to go ahead and go through and solve this. And again, I'm going to need my notes there in front of me. So I'm going to keep on kind of scrolling back and forth and looking at everything. So first of all, you should notice they give you the measurement of little a. And again, lowercase letters are sides, uppercase letters are angles. So what I should do first on this problem is figure out what is h. I got to figure out how many triangles there are, first of all. Always do that as your first step. So this will be 5 times sine of 50 degrees. And it's just stated right up here at the very top. And again, you should have a calculator. I did provide on Power School where you could download a TI calculator. Just again, make sure you're in degree modes. So 5 times sine of 50, and it gives me an answer of 3.8. So my true height on this triangle is 3.8. Now let's go through my checklist and see like which triangle we're going to actually end up with. Is A smaller than H? And again, what I'm looking over here is A is the one on equals 10, A equals 10, and the H is 3.8. Well, that's not true. H is smaller, so we're going to skip the first one. They're not equal to each other. It's very rare that they're going to be equal to each other. I'm going to get rid of that part. Let me rewrite that. Is A greater than B? Well, if we look at this, A is greater than B. Wow, if A is greater than B, then what that means is that we're going to have one triangle. And really the whole process is the same thing as the law of sines, just like assignment number 1. I don't want to waste any more time because that's easy. And again, real quick, if you get one that says this constraint with no triangles, you just write no triangles. Do not solve anything. Move on to the next question. But I want to get into the two triangles because it is a little bit more cumbersome going through everything. So let me clean up my work here. All right, so let's solve this. And notice I'm on a different problem. So H equals B, which is 18 sine of 51 degrees. So again, let me work this out, make sure everything works out. 18 sine of 51 degrees, and I get 13.9. It almost rounds up to 14. I'm going to go ahead and keep it as 13.9. Now, I know what the answer is on this one, so I'm going to go jump straight to it. It's going to be this one. When you compare A, B, and H, and A is 16, B is 18, and H is 13.9, does it follow this constraint? Does it go through the whole rules? Is H the smallest? Yeah, H is smaller than 16 and 18, 13.9. Is B the largest? Yeah, B is 18. It's the largest of these three numbers. So I definitely will have two triangles. I'm going to scroll down because I'm going to need a lot of space to work on this. But really, you're just going to go through and do law of sines. But there is one catch you got to watch out for. So real quick, just do notice there's going to be two triangles. I'm going to have to go through and give me all the parts of the triangle. So let me go ahead and start working on this. And again, I'm just doing the law of sines. So 16 over sine of 51 degrees equals, let's go ahead and do B first, 18 over sine of B. Cross multiply, so when you cross multiply, you're going to get sine B equals 18 times sine of 51 degrees divided by 16. The way you get rid of sine here is that you do the inverse of sine. So do the inverse of sine of all of this. And I'm getting kind of lazy here. I don't want to rewrite that again. So I'm going to put it right there. I'm going to use my calculator to give me that solution. So let me type it in. The arc sine, make sure you do the inverse of sine. 18 sine 51 over 16. And I get 60 point, how many decimal places do they want on this? Round the side lengths to the nearest tenth, round the angles to the nearest degree. So they want degrees to whole numbers, but they want the sides to one decimal place. So I got 60.9. So obviously, if I solve that out, B ends up to be 61 degrees. And that's actually one of my first answers there. It's going to be 61 degrees. If you remember, whenever we were doing all students take calculus, 61 degrees here is the same as 61 degrees here. So really what I need to find is, what is this full rotation? How much is that rotation around? Well, we know halfway around the circle is 180. So if I just take 180 and subtract it by the 61 degrees, 180 minus 61, and it always works out this way, this will be 119. Now the remaining part of the problem, I really just have two triangles that I have to solve. Now, define angle C. So really I got two triangles going on. So it's kind of confusing. You have to kind of like just work on one triangle, then you can move on to the other triangle. For me to find C1, I know A, I know capital A, I know capital B. All three angles of a triangle have to do what? Add up to 180. So if I take 180 minus 51 minus 61, I get 68 for this triangle. I'm going to go ahead and do this one because it's a pretty easy process. Just take 180 minus 51 minus 119. I get 10 degrees. And then to find C, little c as a side, I just have to go back, and let me get a different color pen here, and just do little a over sine of 51 over little c over sine of c, and whichever one I want to solve for first, I'm going to find 68 first. I'm going to do the first triangle, cross multiply, and again, if you did the first homework from yesterday, or I'm sorry, from Monday, you should be well prepared with this. So what is that? 16 Sine of 68 divided by sine of 51. I get 19, and again, remember the sides, they want you to go to one decimal place, so 19.1. Do the exact same thing, but now we have to do sine of 10 degrees. So if I go on my calculator, I should be able to change it very easily. 16 sine of 10 divided by sine of 51. And again, all I'm doing is just cross multiplying. I get 3.6. Let me type that in there, 3.6. Check your answer, and then there's your solution. Two triangles is a little bit more work. I want to kind of conclude at this point because I don't like to make the videos longer than 10 minutes. But definitely go back, practice with this. If you have questions or concerns, I do have office hours at 9 a.m. to 10 a.m. every weekday in the morning. Yes, you will have to wake up early to meet me if you want to see me. But if you text me or email me, I might be able to set up an arrangement. I do have other things going on as well with PSW and other details. So thank you and have a good day.